Hello everyone. So today is gonna be our day 27 of the DSA challenge, and the question that we're gonna solve today is merge two sorted linked lists, right? So this is the question that is given to us. You are given the heads of two sorted linked lists, L1 and list one and list two. Merge the two lists into one sorted list. Okay. So this is important. The list should be made by slicing together the nodes of the first two lists. Okay, so example 1 to 4 is list 1 and 1 3 4, right? Let's just copy this input, paste it here somewhere, right? Okay, so we need to say something like, say this is list 1, 1, 2 and 4, right? This is pointing to null. 1 3 4, this is also pointing to null. We need to somehow create like this is what we require. 1 1 2 3 and 4, right? And this should point to null. This is a sorted. And remember one thing, thus all these separate linked lists are also sorted. These lists are also sorted. Let's discuss the naive solution. Okay. So what does the naive solution look like? Let me copy it again. This should look like red only. Maybe let's take black font, right? Okay. So let's just say I have a container maybe. Okay. So in probably what you can say is, see, since the lists are sorted, right? I obviously what you can do is if you have to go for a brood naive solution, right? Naive solution, what you can do is, hey, I can take an array, not like this. This can be an array because I don't know how many lists are there, right? So go through the list one first. So 1, 2, 4. Great. Again, now go to the list 3, list 2, traverse through it. It will be 1, 3, 4, right? Let's just sort it out. What does this look like now? 1, 1, 2, 3, 4, and a 4. And also here also it's a 4, and then it's pointing to, right? So sorry for the this one. Yeah, this is how our sorted array looks like, right? This is what a sorted array looks like. Now you somehow need to convert to linked lists, right? So this will now look like 1, 1, 2, 3, 4, 4, and null. Is this what our solution is required? Correct. This is okay. Now let's kind of discuss like what is the time complexity of it. Okay. So we traversed time complexity. We traversed through linked list 1, O of n1, plus we traversed through linked list 2, O of n2, plus. Then we sorted this whole array. Okay. Then we sorted this whole array. Great. So for sorting, what is the time complexity? O of bigger N log bigger N, where N is nothing but N1 plus N2. Okay. Plus. Okay. Now we are converting this. Let's just say we traverse through the whole array. Now the algorithm to convert to a linked list from array should ideally look like you will traverse through the whole array. You will create from when you are at in your go you'll go from index 1 till the n minus 1 index. Okay. So here you will start and till here you will go. So like right now my I is at this point. I will create a new linked list. So new linked list and value will be this. Okay, value will be this, and so val will be array of I, and next pointer should be I plus 1. Correct. I plus 1 should be your next pointer. Correct. Now, what does your next pointer should look like? Okay. So let's just say, I mean, see, this also needs to be a new linked list, right? This also needs to be a new linked list. So this is how you will convert it, correct? So let's just say that also takes an O of n greater n. That is capital N, basically this time complexity. So O of 2n plus n log n is your time complexity. Let's discuss space complexity as well. O of n, where n is n1 plus n2, correct? Because you are taking an array. And let's just say you require one more. Basically, you are creating every list, you are converting every index to in a linked list, and this linked list is of size n. So again, an O of n. This is your space complexity. Now your interview might say that, hey, this is not what I required. This is taking very high time and very much high space complexity, so I don't require it. Can you optimize it? So let's jump onto the optimal code. Okay, optimal code. Let me paste it here again. This should be probably green. Let me take this. Okay. So I am given 1, 2, 4. Okay, null. 1, 3, 4. Again, a null. Great. I am given h1. I am given h2. That is the heads of every head. Okay, no problem in that. No problem in that. Great. Let me do one thing. Which do you think out of these two should come here? Okay, which of these would come here? You will say, hey Rohan, this is one. I don't care if any of it comes here. Any of it comes here. Okay, no problem. Let's just say I take one from this list. Okay, and I somehow move my pointer to this pointer. Now my h1 is at this position. My h1 is at this position. No problem. Okay. Now 2 and 1, what is lesser? Since we need a sorted list, since we need one sorted list, so you will say, hey Ron, obviously 1 is shorter, basically smaller. You will, so h2 comes here because this one comes here. Now you compare again h1 and h2's value. Hey, then 2, then 3, then dot dot dot, whatever is coming afterwards. Okay, okay. But how will I get the reference of this one, since my every pointer is moving ahead, and also how will I how will I even start this? This is the question. Okay, okay. Let's do one thing. Let me do one thing. Let me take this whole. Maybe let me copy this, paste it here. This gets deleted. This gets deleted. This was the original thing given to us. Great. Let me create one dummy node, maybe with -1 or whatever value you want to take, and it should statistically, basically, initially, it should point to a null. It should point to null. Okay. Let this be temp1. Let this be temp2. If you remember in every video, since we have done more than 2 videos, now we are at a third video of linked list, right? We generally do not tamper the head one and head two, right? Or basically the head of the linked list. What we do is we create a variable that is again pointing to head only, right? So that we iterate using temp1. So in future, even if we require head one or head two's reference, we can still get it. We can still get it, right? Okay. And let me do one thing. Let me say, hey, you are temp. You are temp. Okay, great. Now, now I will compare my H1 and H2. Sorry, T1 and T2's value. Okay. Since we considered first list here also, let's do one thing. Let this point to this, let this point to this. Okay. So this should look like -1. This goes 1. Cool. Cool. Now this is what? This is pointing to 2, 4 and null, right? But I need to move my temp1 ahead. My temp1 should look like here. Should look like here. Great. No problem. Now I'll compare temp1 and temp2 again. This should point to this now. This should point to this now. Remember, I already have its reference. So even if this gets deleted, I don't care. I don't care about it. Okay, no problem. Temp2 moves ahead. Temp2 moves ahead. Now, if you remember, if you see, this is how my current linked list is looking like. Okay. So temp1, temp2 is here, temp1 is here. Now compare temp2 and temp1. I want this next to point to this. This gets deleted. Okay, no problem. My temp1 moves ahead. Temp2 remains there only. Now, how does my list look like? This goes here, then here, then here, then this. Correct? Remove this. Okay, cool. Blue, right? Yeah. Okay. So temp2 is at 4 and temp1 is at 4 and temp2 is at 3. Okay. Compare the values. Hey, 3 is smaller, obviously. No problem. What you do is this should gets deleted from this and should point to this. Now this is how my linked list is looking like, this one and this and this and this. Correct? Correct? Okay. No problem in that. Temp1, temp2 moves ahead. Okay. Now temp1 and temp4, what is smaller? I'll say that, hey, when it was 1 also, I took first links 1, then why not I take 4 also here? Okay. You get deleted, you point to this. Okay. No problem. Temp1 moves to null. Cool. If temp1 is moving to null, what I should do? I should point everything remaining or in my temporary in my list 2. If temp1 has moved to null, what I should do? I should move everything back to my list 2. Why? Because you remember this list is already sorted. So even if it has more elements in it, 4, 5, 6, whatever, they are already sorted. So this now points to 4 and anything after it is also sorted to it, will also be sorted to it. This is my D node. Cool, cool. Have and same goes, and in any other case, same goes with the case where temp2 has reached, temp2 has reached to null, and now my basically temp1 can now basically point to this thing or opposite of it. If temp2 has gone to null, this can point to this. I mean, I hope you get the analogy, right? Great. Is it sorted? Yes, it is sorted. So what should I return? Should I return D node? Because my temporary would be somewhere here, sorry, would be somewhere here, not this. Temporary should be here. If I return temporary, next thing will be null. This is wrong. Remember, I created dummy node here and that is why I moved temporary. This is the reason why I took temporary and not move dummy node itself. I can simply return dummy nodes next, which will nothing be this. And this will be the sorted list. Great. Time complexity. We are traversing the whole first list and also almost the second list. Okay. So O of N1 plus N2 in the worst case, right? In the worst case, we are traversing the both lists. Okay. Space complexity. Am I using any extra space? Am I? No, I'm not. Why? Because I am reusing the list. I am reusing these list nodes. I am reusing every node. Even if I'm pointing to it, I am reusing it, right? So no extra space. Let's just write some dummy code here, maybe pseudo code. Pseudo code. Okay. I will say that, hey, temp1, you point to uh, head1, temp2, you point to head2, and dummy node, you just be a new list node with value -1 or undefined. I don't care. I don't care because at the end I'm gonna return your next value. So I don't care about you. So okay, no problem in that. And hey, temp, you just be equal to dummy node for now. Okay. While while till when should this loop go? Any of the value, any of the value should not be null. Any of the value should not be null. So temp1 should not be equal to null, and temp2 should not be equal to null, right? If you remember, this is exactly same as in merge sort we did. So when we were when we were learning merge sort, if you remember, we used to merge two sorted arrays. We used to merge two sorted arrays, and this is how we used to do, right? Okay. So what is the thing that I need to do? I need to say that, hey, if my temp1 dot value is less than temp2 dot value, that means the value at temporary one, basically basically this value is smaller to it. This value is smaller to this thing. Okay, then what should I do? Then what should I do? I will say that, hey, you just do nothing. Temp dot next should be equal to you, because you should be the first one to you should be the one that is coming first, and after you temp two's value should come, because you we need to create a sorted list. Okay, great. And temp1 is equal to temp1 dot next. I need to move the pointer. Great. Okay. Else. Okay. So else basically the value at list 2 is smaller. Then in that case, temp2 dot next is equals to temp2. So temp2, you move ahead. I don't care. And at the end of the day, I need to somehow move my I need to move my temp is equals to temp dot next. Okay. But what if there is still some value left in temporary one, or sorry, in list one? Then in that case, if list one exists, so if I say temp one exists, then hey, temp is equals to, sorry, temp dot next is equals to temp one, correct? If there exists some value, else if this is for sure that at least one of this value will be completed, will be done through with in this loop, in this while loop. Yes, this is for sure. Okay. So else temp, I don't need to write if, temp dot next, you become equal to temp2, I don't care. And now return just dummy node dot next. Correct? Correct? Yes. So this is what how my basically my code should look like, right? What is the time complexity? O of n1 plus n2? No extra space, no extra time complexity, just returning everything. Is this what we did? Are we using any extra space? Can you see here? Are we using any extra space? No, I'm just creating one node. That's it. So that is a constant thing. These are constant values. These are constant things. This is constant. So no extra space. Great. Let's try to code it up now. Let temp1 is equals to list1, temp2 is equals to list2. Okay. Let d node is equals to new list node with value, I don't care about it. So let temp is equals to D node, correct? So while my temp1 is not equal to null and at temp2 is also not equal to null. If my temp1 dot val is lesser than temp2 dot val, then I need to say that, hey, temp dot next, you become equal to temp1, and temp1 you move ahead. Temp1 dot next, cool. Else temp dot next, you become equal to temp2, and temp2, you please move ahead. Dot next. And at the end, I just need to move my temporary. If there is some value in temp1, if temp1 is not equal to null, then temp dot next, you become equal to temp1. Else temp dot next, else if I need to check, hey, if there is some value in temp2 as well, then temp2 dot next, you become equal to temp2, and at the end just return d node dot next. Let's try to run this through. Great, accepted. Let's try to submit it. Beats 38.52. Though it's less, but I told you earlier, right? This does not depend on your code. It depends on servers and everything, right? And you can see I wrote this simple code in just in the first go. I'm really proud of myself. How? So yeah, we have discussed this question as well. Uh, needs a dummy node to create a separate linked list, will go same as merging two sorted arrays. Here I can write while loops, and if something are left in list 1 or list 2, deal with it. Let's save this and mark this as done. I hope this question was easy because I told you the analogy, right? You have to think of it like you are solving merging two arrays. It is almost the same thing. It is almost the same thing. Only one thing is new, that is we are creating a new node. And remember this thing. If you are creating a third list, right? If you are creating a different list, you need to have a new list, right? This is kind of a new list, although it is using the, so see, if I open this, okay, I cannot open this. Can I copy this? My left pointer is not working. Okay. Copy image. Great. So see, this is list one. This is list one. This is list two. Separate list. But this is list three altogether, but reusing the nodes of all nodes of this list or this list, right? It is reusing it, but although this is a whole new list, that is why you will always require a dummy node, a dummy node, a node which will initially point to null, maybe with value -1 or whatever value, undefined value can be also. This is important. So just remember this thing. So you require dummy node just to create a new list altogether, right? In every question, this will be used where a new list will be required. Thank you so much, guys, for joining in. I'll see you tomorrow with a video called "Remove nth node from back of the list." Very easy question. Giving you a disclaimer, it uses tortoise hare approach, slow fast pointer approach, or whatever you want to call it. I don't I don't mind. Anything you can call it. So yeah, it will require that approach. Please, if you haven't watched my videos, uh, it was used in find the middle of the linked list. You can go there, check it out, or you can to understand how slow pointer, fast pointer works. You can watch my video. This find the duplicate in an array n plus one in an n plus of n plus one enter what is this integers. Yeah, you can watch this. Yeah. Thank you so much, guys, for joining. I'll see you tomorrow. Bye bye.